Let us solve a problem on parallel magnetic circuits. A cast steel magnetic structure made of a bar of cross section 2 cm by 2 cm is shown in figure. Determine the current that a 500 turn coil on the left limb should carry so that a flux of 2 milliweber is produced in the right limb. Take mu r is equal to 600. So a cast steel magnetic structure is given and its cross section is given as 2 cm by 2 cm. That is, area of cross section is equal to 2 cm by 2 cm, which is equal to 4 cm square. Okay. So cross sectional area is given and we are determine the current that a 500 turn coil on the left limb. So it is given that a coil having 500 turns is wound over the left limb, and determine the current that this coil should carry. So we have to calculate this current so that a flux of 2 milliweber is produced in the right limb. So on the right limb, this is the right limb, this is the left limb, this is the central limb, and this is the right limb. So on the right limb, a flux of 2 milliwebers is produced, and what should be the current that is to be passed through this coil in order to produce a flux of 2 milliwebers on this right limb. Okay. So when a coil is wound over this limb and a current is passed through it, a flux will be produced here. So let us denote that flux as phi, the total flux phi. So phi will be set up in this particular path. So let us name the path. This A, B, C, D, E and F. So this flux phi will be set up in this path B, A, F, E. And at this point phi divides into 2. And the flux carried by this path BE is denoted as phi 1, and flux carried by the path BC DE is denoted as phi 2. Okay. So flux on the right limb, flux carried by the right limb BC DE is given, that is 2 milliwebers. So we can write phi 2 is equal to 2 milliwebers. And other parameters given are the number of turns of the coil, that is 500. Then the relative permeability of this cast steel is given, that is 600. Okay. We have to calculate this particular current. So we know that equation for current is present in the MMF equation. So if we know the total MMF, then we can equate it to N into I and then calculate the current. Total MMF of this parallel magnetic circuit is equal to N into I. So if we can calculate the total MMF somehow, then by dividing the total MMF by the number of turns, we will get the current. So our aim is to calculate the total MMF of the circuit. Okay. Now we know that for a parallel magnetic circuit, the total MMF is equal to MMF of the limb over which the coil is wound plus MMF of any one of the parallel paths. So we can write total MMF is equal to MMF of path BAFE. So it is MMF of this path. Now this path as well as this path are in parallel. So the MMF across them will be the same, and we have to take either one of the MMF. So MMF of path BAFE plus MMF of path BE or path BCDE. Okay, this will be the total MMF. Now how will we calculate the MMF of path BAFE? See. So we know that MMF is equal to S into phi. So for calculating the MMF, we need to know the reluctance as well as the flux. Okay, but we know the flux of this particular path only, that is path BCDE, and we also know that the total flux phi, that is flux produced on the left limb, is equal to phi 1 plus phi 2. The total flux phi divides, and phi 1 is carried by path BE and phi 2 is carried by path BCDE. So total flux phi is equal to phi 1 plus phi 2. Now we have to calculate the total MMF, that is MMF of path BAFE. So for calculating the MMF of path BAFE, we need to know the reluctance of that path as well as the flux carried by that path, because MMF is reluctance into flux. Similarly, then the MMF of path BE or path BCDE. So for calculating the MMF of BE, we need to know the reluctance of this path as well as its flux, or the reluctance of this path and its flux. What we know is the flux carried by path BCDE, that is phi 2 is known. Okay. So as phi 2 is known, we can calculate S2 into phi 2, that is MMF of path BCDE. Which is equal to S2 into phi 2. Let S2 be the reluctance of path BCDE. Let it be equal to S2 into phi 2, which is equal to S2. Reluctance of the path will be length of path BCDE divided by mu 0 into mu r into area of cross section of the path into phi 2. Okay. Now what is the length of path BCDE? It is directly given as 25 centimeter. So we know that the right limb is actually considered from this point up to this point. So if length is given like this, it will be the total length of that particular path. So it is 25 centimeter. So 25 into 10 raised to minus 2 meters divided by mu 0 is 4 pi into 10 raised to minus 7 into mu r, which is the relative permeability of cast steel, that is given as 600, into area of cross section is 4 centimeter square, which is equal to 4 into 10 raised to minus 4, into phi 2. Flux on the right limb is given as 2 milliwebers, that is 2 into 10 raised to minus 3 webers. So on solving this, we will get the MMF of path BCDE. So the answer will be 1658 ampere turns. So on solving the above equation, we will get the MMF of path BCDE as 1658 ampere turns. Now this is the total flux, and the total flux divides at this point and flows through this path and this path. That means these two paths are in parallel. Path BE and path BCDE are in parallel. So that means the MMF across these two paths will be the same. So we can write MMF of path BE is equal to MMF of path BCDE. Okay, so let us equate these two MMFs. So MMF of path BE is S1 into phi 1, and that of BCDE is S2 into phi 2. So we can write S1 phi 1 is equal to S2 phi 2. Okay. Now we can calculate phi 1 from here. So phi 1 is equal to S2 into phi 2. That is MMF of right limb. This is nothing but the MMF of right limb. That is MMF of path BCDE. So phi1 will be equal to mmf of path BCDE divided by S1, reluctance of path BE. So let us calculate reluctance of path BE. So reluctance of path BE will be L divided by mu A, which is equal to, let us see what is the length of path BE. Length of path BE, it is from here to here and it is given as 15 centimeters. Okay. So 15 into 10 raised to minus 2 meters divided by mu 0, that is 4 pi into 10 raised to minus 7 into mu r 600 into area of cross section is 4 centimeters square, that is 4 into 10 raised to minus 4 meters square. So on solving this we will get the reluctance of path BE. On solving this we will get the value of reluctance of path BE as 497,359 ampere turns per Weber. So this will be the reluctance of path BE, and on dividing the mmf of path BCDE by reluctance of path BE, we will get the flux carried by path BE. So we can write phi1 is equal to reluctance of path mmf of path BCDE, or S2 phi2 was 1658 ampere turns, divided by the reluctance of path BE, that is 497,359. We will get the flux carried by path BE, and that will be 0.00333 Webers. So this can be written as 3.33 milliwebers. So we got phi1 and phi2, and we know that the total flux phi is equal to phi1 plus phi2. So phi1 is, we got as 3.33 milliweber, and phi2 is given as 2 milliwebers. So we can write total flux phi is equal to 2 plus 3.33, which is equal to 5.33 milliwebers. So now we can calculate the mmf of the left limb. This will be equal to flux carried by the left limb, that is the total flux, into reluctance of the left limb. So this will be equal to flux is 5.33 milliweber, that is 5.33 into 10 raised to minus 3 Weber, into the reluctance of the left limb, that is L divided by mu A. So length of the left limb is 25 centimeter, that is from B A F E, that is 25 centimeter. So L divided by mu A, 25 into 10 raised to minus 2 divided by 4 pi into 10 raised to minus 7 mu 0 into mu r 600 into area of cross section is 4 centimeter square, that is 4 into 10 raised to minus 4 meter square. So on solving this we will get the value of mmf of the left limb, and we will get the value as 4420 ampere turns. Okay, so now we have already calculated the mmf of this limb as well as the mmf of this particular limb or this particular magnetic path. So we know that for a parallel magnetic circuit, the total mmf will be equal to mmf of that path over which the current carrying coil is wound plus mmf of either one of the parallel paths. So mmf of this path BAFE plus path BCDE will give the total mmf. So we can write total mmf equal to mmf of left limb, that is mmf of path BAFE plus mmf of the right limb, that is mmf of path BCDE. So MMF of path BAFE, that is left limb, we got it as 4420, and that of the right limb we got as 1658. So the total MMF will be 6078 ampere turns. So we got the total MMF, and we know that the total MMF corresponds to N into I, where N is 500. So 500 into I is the total MMF, which is 6078 ampere turns. So we can calculate the current I as I is equal to 6078 divided by 500, and it will be equal to 12.156 amperes.